It's like we kicked it off, man. I think I ended up a little early to this, but here we are. I just want to play some music so I don't crash out. All right, it's going down. All right, so the first thing is I was looking at this Jesus. This Spotify, dude. It's a little too loud. Okay, that's better. Anyway, so I was looking at this what was it, the exam one review thing, right? Somewhere on here. Exam one study guide. There's one part in here that talks about how the first part of the quiz is going to be drawing the unit circle. I can't find any more. Oh, yeah, here we go. You're required to know the unit circle for the first part of the test. This includes knowing all the special angles and degrees, all special angles and radians, and all coordinate pairs associated with these special angles. Unit circle, I hand out for more details. Okay. So that's what I'm going to start with. Right? I think the idea here is you draw the unit circle and then you get to use the unit circle on the test, right? To like assist you in finding the answers. So yeah, I'm just gonna do it. This is super awkward, but all right. And I'm pretty sure you get like a blank one. And I should have printed a blank one out, but that's all right. I'm just going to freehand it. So the easiest part's the angles, right? Because like we've always known the angles in degrees, you know. So like you start out 0 degrees, 30, 60, 90, right? And just keep adding 30 degrees until you get back to 360, right? And for me, I feel like this is the easiest way to start because the rest of it is a little less fun to memorize, or it doesn't come as naturally in the brain. 270, 300, 330. So these are all the 30-degree angles, right? I have to make this a little bigger, just for right now. Yeah, I'll make it small later. All right, then same thing with 45 degrees, right? 45, 90, 135, 180. I think this is 225. This is 315. You're back to 0 or 360 degrees. All right. Then after that, label the quadrants. Feels good to do that, I think. And you can also do the all students take calculus thing. It's like a nice note to remember, right? All sine, tangent, cosine, right? That's for the positive and negative. But beyond that, we can also, this is plus plus, which you can remember this part in your head, but it's nice to write it down as well, I think, because, you know, this is negative x, positive y, negative x, negative y. This is positive x, negative y, right? So yeah, there we go. We're 1/3 of the way done, right? Next thing we got to do, right, is write the conversion from degrees to radians. And like you can actually do this in your calculator, but it takes way too long, right? It's not worth it. So it, you know, essentially you just have to know, really, right? Every 30-degree segment is a pi over 6, right? So 1/6 of pi. And so every time you add a 1/6 of pi, you're going 30 degrees, right? So I'm pretty sure it's right, but I'm just gonna send it and see if it works. So that's pi over 6. 2/6 of pi is pi over 3. Yeah. Why does that look like an 8? Right. Three sixths of pi. That's 1, 2. 3/6 of pi is pi over 2. 4/6 of pi. That's 2 pi over 3. Now make this 5/6 of pi. And then this is just pi. So that worked. We're at pi now. I'll take it. 7/6 of pi. 8/6 of pi is what? 4 pi over 3? 9/6 of pi, 3 pi over 2. 10/6 of pi is 5 pi over 3. Now I'm skipping the 45-degree angles. Just keep that in mind here. I'm essentially using the idea, right, that like 2 pi or 1/6 of pi is 30 degrees. So I just keep adding 30 degrees, right, in my head, you know, and just keep going like that over and over again until we fill it all out. I feel like that's, in my head, the easiest way to remember it all. Like, especially for stuff like 7 pi over 6, like, yeah, I'm not remembering that shit. All right, 5 pi over 3. So that was, what, 10 pi over 6? 11 pi over 6? And then 12 pi over 6 is just 2 pi. So we made it. It looks like it worked. So hopefully, right? So now we have 90 degrees is pi over 2. 45 degrees is half of 90 degrees. So that would make it pi over 4, right? Nice. So we just add pi over 4 to every 45 degrees. And we have to include this, right? It's important. Does that work? Yeah, because 2 pi over 4 is just pi over 2. So now we got 3 pi over 4. 4 pi over 4 is just pi. 5 pi over 4. 6 pi over 4 is 3 pi over 2. 7 pi over 4. 8 pi over 4 is 2 pi. So yeah, there we go. We got all the radians. All we had to remember was the first two. That's it. We're going counterclockwise, right? Pi over 6, pi over 4. Then you just keep adding those until you get the rest of it. So there we go. So we're 2/3 of the way done with the unit circle. I think the next part is like something that you just have to straight up memorize, but it's easy because really it's only 3 values in different orders, right? And I'm going to see if I remember this because I didn't actually double check this before we started, right? But it's something you can do with a calculator as well. You would just insert this value into sine to get the x's, and then this value into sine, into cosine, or sorry, this value into cosine to get the x's, this value into sine to get the y's, right? But that also comes out to be a decimal, and you gotta double check that against your equation, right? So it's just simply not worth it, right? But we can think about this like the closer we are to 0 is going to be higher x values. The closer we are to 90 degrees or 270 is going to be y values. So if we're going, our y values will be higher, right? So a good place to start, right? I think just go ahead and put in the easy ones, right? This is 0 x's and 100% of y, right? Same thing here, but negative. This is 100% of negative x's, 100% or 0% of y's, right? So negative 1x, 0y. We're all the way, but haven't gone anywhere up and down, right? And the same thing over here, right? 0x, 1y. So there we go. Now we just gotta figure out what this stuff is in here. Now the second easy one to remember is all the 45-degree angles are the square root of 2 over 2 for both, right? So it's just start filling those ones out. This is negative square root of 2 over 2. And then positive square root of 2 over 2. This is both negative. And this is positive, then negative. So yeah, all the 45-degree angles are that, right? Then we got in here somewhere, right? We have essentially all right. Now I'm just gonna guess because I don't remember, but that's why I'm reviewing it, because I don't. There's stuff I don't fucking know. But we'll find it. We'll find the answer. So it's one of them is the square root of 3 over 2, right? The other one, I believe, is 1/2. And I'm just going to check it using the calculator. Where is it? There we go. So, we're going to do it in degrees, right? So, sine 60, this will be for the y value, right? Not a gorgeous number, but we can just double check that with square root of 3 over 2. But we gotta get, god damn it. All right, so the y value, square root of 3 over 2 for 60 degrees. Now we'll check for the x value, which I'm pretty sure is going to be 1/2. There we go. It's 1/2. So that's like all you got to do. You just have to do that one time, right? Because you have both of the values and you double check them. I feel like it's always good to double check your math, right? If you don't have it memorized, especially. But now, I don't know exactly how to explain this, but I'm going to try, right? So there's like a pattern. And they're all the same, right? If you flip this over the y-axis, it's the same angle, right? And it's the same distance from the x-axis and the y-axis, right? Like, this is symmetrical, okay? So they're going to be the same coordinates for both sides, right? Except the only difference is the x is going to be negative, right? That's all we got. That's all you got to think about, right? This is symmetry across these sides. So it would be the same thing over here. It would be, I need a better pen. 1/2 square root of 3 over 2. But it's got, the first one's negative now. That's the only difference, right? And you can apply that same method to just flipping it over here, right? Because it's the same. These points on your graph are the same distance from the y-axis and the x-axis as these are. It's symmetrical, right? So it's the same coordinates. Only difference is you're going to use the different, like, negative to positive to, like, place them in the correct position on the graph, right? So this is now negative 1/2, negative square root of 3 over 2. And this one, 300 degrees, is negative, positive 1/2. Positive 1/2. Square root of 3 over 2, negative. Yeah. Beautiful. And we can just test these just to make sure, in case I'm stupid. But like, I'm just gonna double check it, right? So we're just gonna plug in this one, right? 240 degrees, and we're gonna try and find, with the cosine, we're gonna try and find the y coordinate. No, sorry, cosine's the x coordinate. Cosine, I'm gonna write it down. Cosine equals x. Sine equals y. That's not only a coordinate, that is the length from 0, right? We're using this formula to find a length. This is an angle. We're using an angle to find a length, right? So, to turn this angle into length, we use cosine. And the length, cosine just means the length from 0 on the x-axis, right? There you go. Yeah, I don't know how to explain it better than that, but that's the way I think about it, right? Okay, so where are we at? So yeah, that checks out. Negative 1/2. Boom, we did it. And we'll just double check y as well for fun. And yeah, that looks like negative square root of 3. But we will do that again just to remember. Okay, so there you go. So now we're almost done, right? We have our 45-degree angle coordinates. We have our 60 degrees from the x-axis coordinates, right? So that's, yeah, 60 degrees away from 180 is 240. We got the coordinates. 60 degrees away from the x-axis, 300. We got the coordinates. Boom. Bing, bang, bam. I'm gonna like, it's getting sort of hard to see, so I'm just gonna like, frame these so we don't get lost. All right, so the next part, now that we found these, next part's super easy because you can just reverse them for 30 degrees, right? Because 30 degrees from the y-axis is the same as 30 degrees from the x-axis, right? It's just a different axis. So you can always know that like the coordinates for 60 degrees is just the coordinates for 30 degrees backwards, right? Because we're just going from the other axis. It's that easy, right? So I'm just gonna flip them around. Dude, this pen, it's not working for me, man. So here we go. Square root of 3 over 2. One half. Same thing on the opposite side. Is you got a mirror here, got a mirror here, right? It's negative and positive. That one's positive. All right. And then, all right. So I've made my unit circle, and that is the most disgusting thing I've ever seen. I hate my handwriting. But I have some notes here. I think I have my unit circle that we did. That we can test it against, right? The ones that I was really questionable about. I'm just gonna pull it up on the screen. Unit circle. All right, so looks like I nailed it, 100%. All these free points, just for remembering. Power 6, power 4, these values, and then these values here. The rest, like the angles, you can add. You can add power 6 to itself 8 times and accurately. And then the same with 45-degree angle. You only have to add it 4 times and you're good to go. So yeah, that's gonna be that, right? We now have the unit circle. So that's part 1 of the test. So nice. We do that accurately, and it makes the whole test way easier. So yeah, I'm glad we got that out of the way. I think the important part of the unit circle thing, right, is being just very confident in like your method of finding all of the answers and being able to do it quickly. If you don't have it memorized, which I don't have it memorized. I don't know how long that took, but it's certainly not time that you want, you or I want to be eaten out of your time to double check the rest of your answers, right? Because it's important, I think, to be confident in the unit circle if you're going to be testing the rest of your answers against it, right? So there we go. That was brutal. And now it's out of the way. And now we're just going to do the test. Here's a video that I watched to help memorize it. Let me see if I can find it. This is the most succinctly I've seen it explained.
Hey, it's Professor Dave. Let's memorize the unit circle.
He knows a lot about all kinds of stuff. Professor Dave explains.
Math students often have trouble with this thing. It's called the unit circle, and it's just a circle with a radius of 1 superimposed on the coordinate plane with the center at the origin. Then we have all the angles that are multiples of pi over 6, as well as the multiples of pi over 4. And we have to know the sine and cosine values for these angles. Let's quickly go over some key points about the unit circle that will make it very easy to remember. First, we must recall what sine and cosine are. From SOHCAHTOA, sine...
All right, I'm not watching that whole thing again, but if you want to watch it, you now know what the video is called. It was a 10-minute video, made it super easy for me. I'll just put it as a comment in the
Hey, it's Professor
stream
Dave.
chat so that it's like accessible. There you go. All right. Let's take this damn thing. All right, draw the angle in standard position. Sweet. Now that we've done our unit circle, it's like we can pretty easily tell where that is. But, you know, I think where it is may not be enough information, right? Because, like, with the unit circle, we can narrow it down to these two, right? It's over here somewhere, right? If we're looking at the unit circle, we got 350 degrees right here, and then, you know, how do we get there though? We went around the top to get to 315 degrees, right? Not this way. We didn't go this way. We're building this thing. So that's negative 45 degrees, right? That's 45 degrees. That's not what we're looking for. But we just know that because we added our stuff up going this way, you know. So with this type of question, right, it's basically free as long as we're paying attention to which way this line goes, right? And all angles, even when you have to write them out yourself, right, they want you to have that line. It's very important that they know which part is the thing, which part is the angle, right? Can't just draw that, right? I don't know if we're gonna have this as multiple choice or as written on the test. I have no clue, but this is an important detail to know, I think. Yeah. And if it was negative 315 degrees, it would look like this, but this would still be wrong. This is still just 45 degrees. If we had it going around the backside, this could be negative 315 degrees. So the answer, neither of these. Not even close. It's D for sure. Well done. Nice. Love that. All right, only 59 more to go. 900 degrees. Jesus. So for me, I don't know if this is the correct way to do it. What I do is just, right, we got 900 degrees. I'll pull the calculator. This is how I do it, but generally in my head, right? Because, like, it's a pretty easy calculation to make, but we're doing 900 minus the full circle, right? Minus 2 pi, minus 360. We're subtracting the whole circle. Get out of the way. So we got one rotation. Two rotations, and then it ends up at 180 degrees, right? This is our rotations number. This is the full circle. This is how many times we go around the circle before we get to this 180 degrees. So we need two times around, and then 180 degrees. This is not right. This is not even close to 180 degrees. This is like, it looks like even more than 330 degrees. So that's not the right answer. This is like 3 times around. It doesn't even go to 180 degrees either. This is 270 degrees, right? So that's definitely not it. This is the only one that could even be right. This is the only one that is a 180 degree angle, right? Let me just check the math. I mean, usually they give 2. They're like sort of right. Yeah. Looks good to me. So it's got to be C. And it went one time around the circle, another time around the circle, 900 degrees. Let's see. Beautiful. 2 for 2, man. Gotta love that. Only 58 more problems to go. Beautiful. All right. Draw the angle in standard position. 5 pi over 4. So we got a unit circle now. This is great. So we can just find 5 pi over 4, find out where that is, and then draw it, right? But if we don't have a unit circle, which, like, we can handle this in 2 ways, right? We can first thing, probably the actual way to do it, right, is convert it from degrees to radians, right? Radians to degrees. Because it's a little easier, I think, for the human brain to see angles in our head when we see them in degrees, right? So I have the formula to convert degrees to radians. And it's radians times pi over 180. I hope that's right. We're gonna find out. We're gonna see if it works. This is a good time to test if I am doing it. All right. So yeah. I'm a little lost here. Give me just a minute. All right, so we got 5 pi over 4. We're gonna convert it to radians. So we gotta multiply by what? Pi over 180, is that right? Or did I do that backwards? I have no idea. Oh, I did that completely wrong. I'm glad I'm relearning this, right? Because it's like there could be a question on a test where it doesn't give you like a nice looking angle, right? They give you like some weird shit, right? I guess what I'm doing is I could easily answer this question, right, by looking at the unit circle. I want to find the most methodical approach to solving these questions so that it's like sustainable through no matter what the question is, no matter how easy or difficult it is, right? So it looks like anytime you get something like this, I don't know how this is going to work, right? But we'll see, right? I wrote down in my notes that all you have to do is replace pi with 180 degrees and do the equation and you get the answer. So let's see if that actually works. Or if I was just like cracked out when I wrote that. 5 times 180, 900 divided by 4. Wait, what? 225. All right, so I'm gonna look at the unit circle. Nice, that worked out. 5 pi over 4 is 225 degrees. So yeah, that seems like a pretty consistent way to do it, right? Just replace pi with 180, and now you'll have your radians in degree format. So yeah, 225 degrees, it's more than 180, less than 270 is right here in the middle. And we know it's going around too. So everything's great. Nope. This one's close, but going the wrong way. That's 45 degrees. Maybe they're like, oh, there's a 4 and a 5 in there. Maybe they'll get confused. I don't know, dude. There we go. We made it. 3 questions in, dude. Super easy. So yeah, we can just do the same thing here. Draw the angle, standard position. Don't use the unit circle. My unit circle was eaten by my dog before class. I had a stroke when I made my unit circle, so everything was wrong. But now I'm good, so I'm gonna double check it. 3 pi over 1, or 3 times 180. Whole thing over 4. 135. But very important. There's that negative, dude. Sometimes you can barely see it. There's that negative coming to fuck everything up, coming to ruin your entire life by making you get this question wrong, and then you get a 69.5 because you didn't see the negative and like lose your scholarship or something. Now I gotta go, like work at Starbucks or something and get yelled at by a boomer on Facebook. All right. 135 degrees. It's too much, dude. 135 degrees. 3 pi over 4. 135 degrees. Checks out. 135 degrees is between 90 and 180. Exactly halfway, right? So like 180 minus 35 degrees. 145. Shit. Minus 45 degrees. 90 plus 45 degrees. 135. All right. So we know these are the closest axis, right? So we know it's halfway between those, right? Ideal. But that negative, dude. Negative's coming back to get me, man. So we got to go 135 degrees, but like the opposite way, right? That's too much. That's like 315 degrees the opposite way. That's going the opposite way as well, but like only 45 degrees. This one doesn't even include the negative. This is the one that you lose your scholarship on right here. Because see, it's the right answer, but it's going the wrong... Wait, no. That's not even the right answer. I don't know, man. This is the right answer. And it's going negative. It's going clockwise. It's going that away. 135 degrees. Beautiful. Hell yeah. Ah, here we go. This thing we did earlier is coming in handy, right? What we do? We did the... we did something. Oh yeah, we just put 180 degrees in there for pi. So how do we do... I don't know how we do that in the other direction though. I'm gonna look at the notes. It's gotta be in the notes. Degrees to radians. I'm gonna go to the restroom. I'm gonna think about it. And we're back. Converting radians to degrees. If we want to do it the easy way, I'm going to do it the easy way and the hard way. But I'm going to do it the easy way first, just so I know I'm getting the right answer. $205 degrees, right? That's not on the unit circle. It's gonna be somewhere between 180 degrees and 210, right? This is the very difficult way, right? There are 30 degrees total between 210 degrees and 180 degrees, right? We can divide that into... Wait, we're converting this to radians. Either way. We can divide 6 pi, or pi over 6, into 6 portions, right? So we got pi over 6. Divided by 6 is going to be pi over 36, right? Please. This is the much more difficult way, I think. And we've discovered the hardest way to do it. So yeah, now we just do, this should be 5 degrees right here, right? So we just do 210, which is 7 pi over 6. And subtract pi over 36 degrees from that. Which now we gotta make the denominators match. So 7 times 6. Now we got 42 pi over 36. And then we just subtract 1 pi. So we got 41 pi over 36 should be the answer. Can we simplify that? I don't think so. So I believe that's the answer, but I'm gonna do it in the proper way, just to see. Let's just see. Now I'm pretty sure I wrote the proper way in the notes somewhere. Where's that freaking calculator? Did I exit out of it? Oh no, it's right here. All right. In my notes it's saying to convert degrees to radians, which is what we're doing. I put r times pi over 180. So let's see if that's correct. So we got 565 times pi over 180, which then we just move this up here, right? Then divide by 180. Oh, okay. So what I did, the problem with the first one, right, is I left out the extra degrees here. I like completely forgot to add 2 pi to this. So this is plus 2 pi. Yeah, there we go. Which in this case would be $72 pi over 36. We get 41 plus 72. So it'd be 113 over 36. So yeah, that's the much more difficult way to do it. This looks like the easy way to do it. I don't think either of them is simplified. But we just use that function on the calculator, right? Nope, that's the simplified version. So 2 ways to get the right answer. The incredibly difficult way to prove the answer, and then the formula, which once again is all you do is take this number, put the letter pi next to it, and then put 180 degrees under it. That's it. So this, if we're doing this, we just put 180 degrees at the bottom over a thing, and then we make sure to put pi next to our answer on the top, right? So this is the wrong answer because this is only for 205 degrees, right? Which, not the answer. The correct answer, as we've discovered, is this, which is a simplified version of this, right? We can double check that too. There we go. 113 over 36 pi. Whoa. Custom formula sheet that we remember things about life on. So, one of our nice formulas that we can remember to write down is this one. This is radians to degrees, which is r pi 180, right? That's it. R pi over 180. I just wish I didn't have to use markers. I wish I had a pen that works. Yeah. R pi 180. And then what was the one for the opposite way? The other way around, you have your degrees. So we'll put this angle sign. It's probably impossible to see. Angle sign degrees. Times 180. Replace pi with 180. So get rid of that. I don't know. I think I'm confusing myself. All right. Convert the angle to radians in degrees. In radians, 2 degrees. What we just do? We did it the other way. So yeah. All we got to do, replace pi with 180. Well, that's what I said earlier. Now let's see if that still works. Don't you have to write that down as like a math formula, right? I think that's where I'm throwing myself off. Like, it doesn't have to be a math formula. It's just, you just have to remember when you're going this way, these are just interchangeable somehow. Oh, there we go. Pi and 180 degrees are always interchangeable. That's a good way to remember that. I don't know, dude. I really don't know. I'm trying to like have some eureka moment about this, but I think sometimes you just gotta memorize. You know, you just gotta memorize the answer. Or the formula. 675 degrees, negative 675 degrees. Let's see if that works. I'm gonna double check it on my own first, because I won't be able to just use check answer when we do the test in real life. I'm gonna have to know the answer. Like if I want to get 100%, right? I have to know. I can't just like hit check answer. That's what I hate about this homework, right? Is that you can sort of just keep guessing until you get it all, you know? And it makes me mad because it makes me sort of lazy, right? I like the problems where it like makes you do it step by step, so that if you get one part of the step wrong, you have to go back and do the entire problem again to get the full credit, right? Okay. So how are we gonna double check it? I had an idea for this earlier. Oh yeah, okay, so we just need to subtract 2 pi first. That's step 1, right? Because this is more than 2 pi. And I'm just doing that to put it into something that we can look at on the unit circle, right? But we have to remember to add the 2 pi back in later. Deal? So 2 pi is 8 pi over 4. And negative sign, I'm just holding off on that for now. I'm going to add that back in later too, right? Just because it's going to confuse me. So 15 minus 8, that's 7. 7 pi over 4. All right. Which, looking at the inner circle, looks like that's 315 degrees. And we are gonna add our 2 pi back in, right? So I said we have 315 is 7 pi over 4, 315 degrees. We gotta add back in our 2 pi, which 2 pi is 360 degrees. There we go, 675. Looks like our answer's right, except the negative, dude. The negative to ruin our chance at defeating capitalism. All right, there we go, man. Negative 675. And we had 2 ways to find it. Convert the angle to a decimal in degrees. Jesus. Now, I hate this because I've never, ever in my life seen a decimal in degrees once. Right? I'm sure I will someday, right? But it's just like, this feels, of all the things we learned, like the most esoteric, right? And like the problem is simple. It just comes down to memorizing what the conversion is, right? And it feels very unintuitive, and it's very easy to forget, I think. That's just my opinion. I'm not a doctor. So this is minutes, this is seconds, right? Minutes is easy to remember because it's just times 60, right? This one stresses me out because it's like, where I know if you're going one way, it's 3,600, you know. So I'm just going to wing this and see if I can get it right. This is 18 out of 60, right? So that's 0.3. So we got our first decimal. We got 26.3. Now I think this part here just starts on the next decimal over and contains 4 decimal places, but I'm not totally sure if that's right. But I'm just going to try it. See what happens. 41 over 3,600. And the bottom has 4 decimal places, right? So important. We can't just like insert this anywhere. There's some specific order to it, right? Yeah, let's see that's correct. So 26.3113. They want 4 decimal places. 114 because we got to round up. So we're just going to put I think this accounts for our first decimal place. So I didn't copy it. That just works out though that it's the next one. I don't know if this is going to be right, and I have no other way of like verifying it. So we'll just see. Nice. Feels good. So I love when stuff just works. You know what I mean? Filling in a circle. I'm gonna write degrees to radian. Wait, no. Minutes per degree. Is in every degree there is 60 minutes. And then what's the other one? Seconds. In every degree there's 3,600 seconds. So you just insert your degree, your seconds and minutes value into those two equations, right? 18/60ths and 41/3600ths is basically all this is saying, right? Now they're gonna make us do it backwards, and I'm like even less confident about doing it the other way around now. Find the length of S of the arc of a circle of radius. Find the length S of the arc of a circle of radius. Dude, this is another thing I hate about this website here. It's just like, dude, what is this? Find the length S of the arc of a circle of radius 70 meters subtended by the central angle 81. Like, dude, what a horrible sentence. There's got to be a better way to ask this question, right? Find the length S of the arc of a circle of radius 70 meters subtended by the central angle 81. That is not English. It can't be. There's no way. Find is the verb. Then you got like 4 nouns. And then another verb. And then some more nouns. I feel like you can't just go verb, noun, 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 verb, noun, noun. Well, that's just my opinion. I'm not an English guy either. All right. The length of the arc. So we're finding arc length. Okay. Cool. Which they already tell us that in the answer. So it's like nice. You can just kind of leave this part of a circle, like this part, not important. All right. So of radius 70 meters subtended. By the central angle at 81 degrees. So I don't know what subtended means, but I think somewhere in my notes. There's a function for this. Okay, so we know the radius. That's great. Wanting this to later. Wanting this to later. Wanting this to later. Wanting this to later. God damn it. I did not write down the arc length formula. And I don't remember what it is. This is sine function graph. Oh, here we go. Radius times radian equals arc length. Radian degrees. So it's just 70 times 81. That can't be right. It can't be that easy, right? Length of the S of a circle of radius 70 meters. It can't be that easy. I feel like I must have written that down wrong. Or do I need to convert its radians first? I think I need to convert its radians first. Let's try that. So we got this answer. I don't think that's right. I'm going to try converting its radians. But how did I do that? Was it degrees times pi 180? 9 pi over 20. So let's try that. 70 times 9 over 20. 31.5. 9 pi over 20. 98.960 is what I got. 98.96. I guess that makes sense, right? Because pi is an actual distance. I don't know, man. Pi is like a I don't know, dude. Maybe that's the purpose of radians in the first place. No way. Let's fucking go, dude. Wow. Nice. Okay, so that was just convert degrees to radians. And then it's just the radius times the radians gives you the arc length. Cool. On the area of the sector of a circle of radius 9 meters formed by an angle of 60. Jesus. Okay. So, sector of a circle, radius 9 meters, the angle is 60 degrees. That's a bunk. 60 degrees though. I'll try it again. There's 90 degrees. Here's 60. That's 45. Here's 60 degrees ish. Okay. 60, 90. We're finding the area. My note still looks like it's just radians times radius squared. So let's try that. So 60 degrees is pi over 3 radians. So that would give us pi over 3 times 9 squared. Let's see what we get. $84.823. It's 84.82. 2 decimal places. God damn it. Oh, they give us the formula here. They're not going to do that on the test. One half. I was missing the 1/2 part. 1/2 of the radius squared times the angle Is that as simple as just dividing this by 2? If not, I have another idea. I feel like maybe you got to do part of this dividing in half thing beforehand. Ugh. All right. I guess, so why is it half instead of both? I guess radius squared. Where does the 1/2 come from? That's what's confusing me. Maybe because radians. I don't know. A gondola. 14 revolutions. God damn it. Dude. These conversions are important. Like being able to convert stuff to stuff is important, but like oh, okay. I gotta change the music. I'm not allowed to play copyright music on YouTube, I guess. All right. I do have this formula. I know this is important to know. And I'm about to take physics classes. And they're all going to be like very similar to this. But however, this shit stresses me out. Okay, so what do we got? $14 RPM. Got a gondola. 22-foot radius. I somehow just lost page notes. That's all right. So I guess we're finding the circumference, right? That's what it looks like. That's an important step in this. Circumference is 2 pi r. I guess r in this context referring to radians. No, that's radius. So the radius, 22 feet. So we got 2 pi 22. This distance happens 14 times every minute. So first, I guess we convert this to miles per hour. This is where I put the miles. I don't even know what the length of a mile is. Is it 5,000 something feet? $5,280. What a disgusting number. Did they just make it intentionally this way so that it would make it much more difficult to learn math? So they can gatekeep knowledge easier? That sounds like some old English type of shit. Hour. So I know. This is the distance. It's either this times 60 or this times 1/60th. I believe that's it, but I don't know. But we're gonna. I could be totally wrong too. So 2 pi 22. I mean, I think it'll be easy to tell because of the speed of the gondola. You know what I mean? But we'll see. Like, one is gonna be a really fast fucking gondola. Okay. It's giving me 1.57 miles per hour, but that seems way too slow. So let's just I'm gonna try and logic this real quick. See if I can't just like figure it out before looking up the answer, right? So this thing spins 14 times. every minute. So how many times would spin in an hour? That's 14 times 60. Jesus. $840 times per hour. Every time it spins, it travels this distance. So I need to multiply this by that to see how far it's traveled total over this hour in feet. So it's traveled this many feet in an hour. Now all we have to do now is divide that by how many feet there are in a mile. So now it's traveled 21.99 miles in the hour. And 2 decimal places, 1 decimal place. So it'd just be 30. God. R times Wumbo. V. Let's run it back. What is V equals RW? Is that supposed to be? I'm like very close to skipping this problem. Okay, 14. Every minute. Happens 14 times. 14 times every minute. 14. Fourteen times 60. Okay. 840. It happens 840 times per hour. It goes around in this circle where the radius is 22 feet. Linear speed, is that the circumference? It's got to be, right? Because this is all the values they give us, right? It's got to be the circumference. I don't even know what it said. Either way, we're going to try that again. Instead, let's do pi r. Maybe that's it. No, because it's traveling the whole circumference. 2 pi 22. And it should be that times... Oh my god, I just rounded it wrong. I think I got the right answer. It should be 22. We're about to find out. Whew. Dude, thank God that like you're able to show your work on this test. Because at least I worked it out right. I just like didn't split screen the calculator so I could see. I saw all the nines and just started rounding nines until I got to 30. Ugh. All right, we're 1/6 of the way through the test, and it only took an hour and a half. That's pretty good. That's pretty freaking good, dude. So for a 2-hour test, I just have to be able to do the next 50 questions in 30 minutes. But it's not going to happen. So I guess we're going to run it back at some point. You know? Diameter of each wheel of a bicycle is 27 inches. So that's our radius, 27. R. There's gotta be a pi in there somewhere. We're doing the same thing as the last one. We're just doing it backwards, I think. Because now it's giving us how fast it goes. And we're trying to find the revolutions per minute. So I'm gonna start over. And not use red, because it's actually making me mad. Okay. So it wants to find minutes. So we gotta go ahead and just convert this to minutes. 35 miles. How many? 35 miles per hour. So we're gonna divide that by 60? I don't think so. We gotta... No, yeah, it's divided by 60. 35 over 60. Because it... No. I think it's 35 times 60. No. 35 miles per hour. But it'll travel less miles in a minute. So, yes. 35 over 60. Which is like a pretty decent looking fraction, actually. $7.12 of a mile per minute. $7.12 of a mile per minute. Here's the bicycle wheel. Here's 27 inches. I don't even know if the inches matter in this case. No, they do, because we have to convert miles to inches, of course, probably. Jesus. This one's hard even for just like pure logic. So first I gotta find the circumference, right? So 27 times pi. Times 2. All right, so we get this lovely number here. It travels this distance every rotation. I guess we also have to do the miles to inches conversion. So that's 35 miles times 5280 to get feet times 12 to get inches. Inches total. So I guess now it's just is this per minute? So now I divide it by 60. Okay. I think I divide this by 60. Because that's inches in an hour, right? I need inches in a minute. Dude. I feel like this question could be just one question. I feel like I don't know. It's a lot. It's a lot for 18 out of 168 points, you know what I mean? I don't think that's how the test is going to be, but it's just like, good lord. So, this is how many times it travels per rotation. This is how many times it travels per minute. So we need to find how many of these happen in this. So we divide this by this. Please, dear God, be correct. So I just take this number, put it in there. So it looks like 25.9 revolutions per minute. God. Oh, 1 decimal place, please. Is this like an order of operations thing? That seems like a reasonable number. Is this a significant digits thing? No? Okay. This number is the inches per minute. This number is the... I don't see how this could be wrong. That's it. I don't understand. Try it again from the very beginning. "27 inches. Like, I don't even want these freaking points, dude. This is terrible. 27 inches is the diameter. Holy shit, that's the answer. I use this, dude, this is about to ruin my life. This freaking... about to make me die in poverty over this word right here that I just glazed over. Alright. Thanks, my lab Pearson, for trying to make me homeless. Okay, so I have most of the work done then. It's this. I think I just need to take this 2 out because I already have the diameter. What? Why did I put 227? Oh my god. Okay. Pi times diameter, because the diameter is 2 radiuses, right? So pi times the diameter gives us that, and that's how many times. That's how many inches happen in one rotation of the bicycle wheel. So I just need to use this number as the bottom part of this ratio. This is, please be right. 435.7. It's gotta be this, right? I was thinking that looked like a low amount, right? But no shit. Let's fucking go. There's no more satisfying a feeling than doing an entire problem right. Just to notice that you made a typo in the calculator and then use the wrong one of the 8 different factors in the equation. How you had to decipher off of a 6-inch area written in 8-point font. Find the values of sine, cosine. Oh, I actually enjoy doing this one. Okay, so this is straight from the unit circle, right? I'm assuming P means what? What does that actually mean? At the point on the circumference of the circle? The position? Is that position? I don't know, it doesn't matter. We don't know what the radius is. Oh, unit circle. Real number T. Okay, so they're just taking the radius. They're like not factoring the radius at all. So we can just like plug and play this stuff. Sine formula is just x or y. It's y straight up. So it should just be the square root of 3 over 2, right? Please? All right. Sweet. This is the easy one. 1/2. Tangent formula is y divided by x. So that'd be this would be a square root of 3 over 1, aka. Wait, is that just it? Square root of 3. Did I do that backwards? No, I did it the right way. I'm just always after that problem we just did, I'm just like expecting everything to be way too complicated. Which is like sort of a win, right? So CSC, the inverse of sine. So it'd be 2 over the square root of 3. And then we got to do the square root of 3 times the top and the bottom. Beautiful. Secant is the inverse of cosine, so that's just 2. Cotangent is the inverse of tangent, which would be the square root of 3 over 3. Sorry. 1 over the square root of 3, which is just the square root of 3 over 3. Because you have to do the square root times both sides, right? Like this is what we had before. One square root of third. Oh. Equals 3. Equals square root of 3. Nice. Time is it? Oh, dude, we got so much time. I'm like blowing through them now. Find the exact values of 6 trigonometric equations. Trigonometric functions of a given angle. If they are not defined, say not defined. Do I use a calculator? Assuming the radius is 1, assuming the radius is 1, right? That's what we're doing, right? Assuming the radius is 1. I'm gonna. Do we need? I guess it. Oh no, because these are functions, so it doesn't matter. Or does it? I really don't know. Oh, that's cool. So we're using the unit circle. 3 pi over 4 is negative square root of 2 over 2 for x, so that should be sine, and then just the square root of 2 over 2 is y. So oh no. I don't think I can actually write on a page. Whatever. I can remember it. I'll just gotta remember the negatives, right? I think that's the part that's gonna fuck me up. So this is just straight up square root of 2 over 2. Because we're in the second quadrant. This should be the negative square root of 2 over 2. I found out recently there are hotkeys for like typing every possible mathematical equation, but I don't actually have a number pad, so I can't do it. This is negative because we're in the students quadrant, and it's square root of 2 over the square root of 2. Which, is that just 1? Is that negative 1? Nice. Cotangent. The inverse of negative 1 is negative 1. Right? Secant is the inverse of sine. So it's 2 over the square root of 2, which is 2. That's gotta be right, yeah. Oh my god. What have I done? Oh no, this is the inverse of cosine. They flipped it. They turned it around, man. Just to mess with me. They did it back. Huh? Secant is the inverse of cosine, right? I'm sorry. I don't understand how that's wrong. Check it with the calculator. Is this undefined? Can secants just not be negative? Oh. The scientific calculator doesn't know secant. So it's cosine. But it's the inverse. And my answer is 2 root 2 over 2. So how did I get that wrong? Dude, I might freak out. What am I missing here? Okay, I don't know how you express this. I don't understand. Dude. How? Oh my god. I just didn't simplify the fraction. I can't tell you how difficult it is to like go through life being this stupid. It's basically impossible. And it's negative, right? It's supposed to be negative. Please God be negative. Alright. This is cool. I'll remember that. I'll remember that for next time. I'm just gonna throw this last one in there. Good Lord. My brain is fried, man. There's a lot of material. Cosine 2 pi. Cosine is x. This has got to be 0, right? What? Oh, no, it's 1. It's 1. Y is 0. X is 1. The cotangent of, what is that, 90 degrees? Yeah. So that's, what? Cotangent is y divided by x. So that's 1 divided by 0. You can't do that. What? Oh. Huh? Oh no, I was thinking about tangent. It's x divided by y. I need to like work through these a little slower. Tangent of pi. Tangent is y divided by x. Pi is 180 degrees. Y is 0. X is -1. So this should just be 0 again, right? Cosine is the x value. Cosine of pi. Pi is 180 degrees. The x value is -1. Sine of 40 pi. 40 pi is the same as 2 pi. The sine is 0. Forty pi is the same as 2 pi because it's just 20 revolutions of 360 degrees, right? So no matter what, if it's a multiple of 2 pi, it's always just going to be 360 degrees. Cotangent of 45 degrees. 45 degrees is square root of 2 over 2, comma square root of 2 over 2. Cotangent is the division between those two numbers. So it's the square root of 2 over 2. It's the square root of 2 divided by the square root of 2. I think that's just 1. Cosecant. The inverse of sine. Cosecant. The sine of 60 degrees is square root of 3 over 2. But we need the inverse. So it's this one. Secant is the inverse of cosine. Pi over 6 is 30 degrees. So it's 2 over the square root of 3. Secant is the inverse of cosine. So that's the x value. Yeah, we're good. I think that's it. Nice. Pi over 3. Cosine of pi over 3. Pi over 3 is 60 degrees. Cosine is x. This is 1/2. (19 pi over 4) is the same as 3 pi over 4, right? Because we're going to subtract 2 pi until we get to a reasonable number. AKA, we're going to subtract 4 pi over 2 until we get a reasonable number, which is 8 pi over 4. So we can take that off 2 times. 3 pi over 4 is 135 degrees. We need the secant, which is the inverse of cosine. And the cosine of 3 pi over 4 is negative square root of 2 over 2. We need the inverse, which is... I'll never ever forget this again because of how much pain that just caused me. Alright, now this is what we gotta do. This is what I gotta... Wait. No. This is what I got. I'll never ever ever forget this again. And it's negative because it's in the second quadrant. What? Bro. Did I do it right the first time? Got 3 pi over 4. Negative square root of 2 over 2. Over square root of 2. Dude, what did I do wrong here? Let's just convert this to degrees to make sure I'm at the right place. Yep, I'm at the right place. And the secant is definitely the inverse of cosine, right? I don't know, man. I need to retake algebra. This is bad. This is 45 degrees. Sine of 45 degrees. Square root of 2 over 2. This is 30 degrees. Pi over 6. $30. Cotangent is x divided by y, which x in this case is square root of 3 over 2 divided by 1 over 3. Or the square root of 3 over 3, right? No. Oh, God. Oh, I just put the wrong. Okay. We're chilling. It's fine. It's totally fine. I just can't read my own handwriting. I missed a chat from someone because I don't have some sort of what is it? Like a notification, like a sound notification, but that was like 35 minutes ago. But it's all right. I appreciate you trying to help me. I think that was like in the time where I was crashing out, like not able to solve the problem. And the chat, whatever they typed, that was retracted, probably would have been like very helpful, you know. But it's all good. Next time, you know. All right. Use calculator. Find the approximate value of the expression rounded to 2 decimal places. Okay, so this is just the one where you just type in the answer, right? I just got to make sure it's in degrees. Dude, I figured out what I was doing wrong just now earlier. I was trying to plug in. I'm going to move past it. Rounded to 2 decimal places. So it'd be 0.79. Oh, and it's multiple choice. Like, how much easier could it get? This is dude, this is another thing with this Pearson that like kills me. It's like you have a question that takes half an hour and then they give you a question like this where it's just like you barely have to use your brain. And then like the other one just like sneak up on you out of nowhere, man. I guess that's how life is though, if we're being real. That's how life is. It's like easy, 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 impossible, easy, 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 impossible. Right? Pi-8. Gotta make sure it's in radians though. So I don't have a psychotic break. 0.92. Huh? Oh, it's secant. It's secant. We're good. Can't do secant on a scientific calculator, so it's 1 over cosine. .082. Beautiful. All right, so I think we have time to. I think we have time to do the next 3, and then I'll just do another session for the last 30. Find the exact value of the expression during his calculator. This is one of those where you cancel each other out, right? So we got. cotangent is equal to cosine over sine. CSC is equal to the inverse of sine. I mean, I just feel like I almost feel like instead of doing this bullshit, it's just easier to like take the numbers from the unit circle and then do it that. But I'm sure after like the second exam, I won't feel that way. This just feels like very foreign still. So I'm gonna try it the other way. CSC of 30 is 2. Cotangent of 45 is 2. Or the square root of 2. Cotangent is... Oh, it's 1. Is it 1? It's 1. Because it's the square root of 2 over 2 divided by the square root of 2 over 2. So the answer is 2. Yeah. Secant pi over 4. This is just 5 times the square root of 2, right? Plus 7 times one. Is this 2? Secant. No, it's the square root of 2. I mean, but they're not gonna let me write like a incomplete. Right? Like that's still a math formula, right? Okay, I guess not. I guess that's an answer. That's an exact value, apparently. I guess it is like a binomial, right? I don't know, man. Domain of tangent function. I think this is like the proper place to stop. Yeah. Look. Wait. Oh no. I thought we were halfway through. It seems like the proper place to stop though, because this is like we've kind of gone all the way up until the past 2 weeks with this review. I'd love to do the whole thing right now, but my brain is pretty fried, and I think I'm just going to get increasingly frustrated. By the way, if you did stop in to hang out for this experience, thank you. for being really into math. You know, I hope watching me suffer through this was entertaining, as well as like educational. I had fun. I feel like I learned something. Anyway, thank you, and good luck. See you tomorrow.